Dear students, in today's session, we can solve two problems from the series combination of resistors. So this is our first example from the resistors and conductor series. Example 12.7. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 volt battery. Calculate the total resistance of the circuit, that is the series resultant resistance, and the second one, the current through the circuit, and the third one, the potential difference across the electric lamp and conductor. So this is our question diagram already given. So I will show you how the way we have to solve the problem. I have redrawn the diagram. Here two resistors are there. So first can be represented, then the first one is the resistance of the conductor can be represented by R1, and the second can be, that is the lamp, can be represented by R2. And a battery of 3 cells. Here you can see 3 cells. 1, 2, 3. Isn't it? So 3 cells are there, and all the things are ammeter key are also given in the question itself. So before solving the problem, the first question is to find the total resistance of the circuit. Here you can see that these two resistors are connected in series. That is, one end of the conductor is connected to the one end of the bulb. Isn't it? So just remember the equation. Now we can move to the solving part. First, we have to write the quantities given in the question. The first quantity is the resistance of the lamp. So I have written the resistance of the conductor R1 equal to 4 ohm, and the second one is lamp. The resistance of the lamp, that is represented by R2 equal to 20 ohm. And one more quantity is also given, that is the potential difference of the circuit, that is 6 volt. So it is represented by V equal to 6 volt. Now we can solve the first part. The first part is to find the total resistance of the circuit. The total resistance. See, here the resistors are connected in series. So it is the equivalent resistance is represented by Rs. R is equal to, what is the equation? Here two resistors are there. You have to just find the sum. R1 equal to R1 plus R2. Now substitute the values. Here R1 equal to 4 ohm, 4 plus, then R2 equal to 20. Then our answer will be 24 ohm. So the total resistance of the circuit is equal to 24 ohm. So we have answer for the first sub question. Now we can move to the second sub question. B. The second question is to find the total resistance, the current flowing through the circuit. See, just remember the derivation. In series combination, the current flowing through each resistor will be same. So there is only one value for the current. Only to find I1, I2 and all. But the potential difference are different. So here we have the total potential difference, and total resistance we could find as 24 ohm. So just write down the total values. Resistance Rs, that is the total resistance, R is equal to 24 ohm. And what is other quantity given? That is potential difference, V equal to 6 volt. Then now we can find the total current as, that is the current through the circuit. Current through the circuit is represented by I equal to, now we can apply the Ohm's law. I equal to V by R. Here R can be represented as Rs, since it's series combination. Now substitute the values. That is V equal to 6 divided by 24. That is 1 by 4 equal to 0.25 ampere. So our answer is 0.25 ampere. So the total resistance of the circuit is 24 ohm, and the current flowing through the circuit is 0.25 ampere. Let's move to the last part of the question, that is the last question. Here you have to find the potential difference across the lamp as well as the conductor separately. Just remember that the potential difference across each resistor are different in series combination, but the current flowing through the resistance are same. So first we can find the potential difference across conductor. Make sure that since we have represented the conductor as 1, then we can represent the potential difference across conductor as V1. and similarly we can represent the potential difference across the lamp as V2. So what will be the equation to find the V1? V1 equal to I into R. We are just applying the Ohm's law. V equal to IR, I into R. But here the current is same, so no need to represent I1. But the resistance is different, so V1 can be written as I into R1. Is it clear? V equal to IR is the general equation, but here you have to find the potential difference across the first conductor only. So it is represented by V1, and so normal equation will be V1 equal to I1 into R1. But the current in the series combination is same across each resistor, through each resistor. So now you need to write I1. So we simply write V1 equal to I into R1. Substitute the values, then 0.25 into what is R1? R1 equal to 4. So what will be the total potential difference? 0.25 into 4 equal to 1 volt. So the current and the potential difference across the first conductor equal to 1 volt. Similarly, we can apply the same equation in order to find the potential difference across RT. So potential difference across the lamp is represented by V2. V2 equal to I into R2. Now to write I into R2. Simply we can write I. Substitute the value 0.25 into what is R2 here? 20. Just apply the math. 25 into 2. Here one positive digit number are there. So we can simply multiply 25 into 2. Then that will be equal to 50, isn't it? Then 1 0 is remaining. It will be 500. Just count the number of decimal digits. 2 digits are there. So count from the right side. 1, 2. Here will be the point. So what will be the answer? 5 volt. Now I will give you a trick in order to check whether your answer is correct or not. The simple one is in the previous derivation we have like V equal to V1 plus V2 plus V3. There are 3 resistors. Here only 2 resistors. So we can write total potential difference of the circuit, that is the voltage of the battery will be equal to V1 plus V2. Isn't it? So we got V1 as 1 volt and we know the total potential is 6 volt. 6 volt equal to 1 volt plus V2. Just minus 1 from total, that is V2 can be find out by V minus V1. Just rearrange the equation, then you will get V2 equal to V minus V1. Then substitute the value 6 minus 1 equal to 5 volt. In this way also you can calculate, but better you write the equation of Ohm's law and substitute. There are 2 methods in order to find the second potential difference. In this problem, we have to draw a diagram. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each. So we have to draw a battery which consists of 3 cells, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor. There are 3 resistors and a plug key all connected in series. So we have to draw the circuit diagram for this case. And the second part is also the redraw the circuit of question 1, putting in an ammeter to measure the current through the resistors and voltmeter to measure the potential difference across a 12 ohm resistor. There are 3 resistors, but we have to connect the voltmeter in order to read the potential difference across 12 ohm resistor. So we have to connect only one voltmeter. What should be the readings in the ammeter and the voltmeter? After that, we have to calculate the readings in ammeter, that is the total current flowing through the circuit, and the potential voltmeter. Voltmeter reading will be the potential difference across the 12 ohm resistor. In the first part of this question, we have to draw the diagram, circuit diagram. See, here they have given like a battery of 3 cells of each 2 volt. So the battery consists of 3 cells. So we have to draw a battery. Now I am going to draw the battery, the first cell. Okay. Then we need one more cell. Connect the positive terminal of the second cell to the negative terminal of the first one. Again we have to connect one more cell. So what will be the total potential difference of the battery? That will be equal to 2 plus 2 plus 2. That will be 6 volt. Is it clear how to draw the battery? Now we have to connect the resistors in series. 3 resistors are there. I represent the three resistors R1, R2 and R3. The first one. So we can simply draw the three resistors connected in series. First resistor, then second, then third. Once you draw the diagram, then we have to name it R1, R2 and R3. And what are the other things given? A plug key. So I am connecting the plug key here only. So what is the direction of current is? The current flows from the positive terminal of the battery to the negative terminal of the battery. So this will be the direction of current. Let it be I. A plug key. It's represented by K. Then we can write the values 5 ohm, 8 ohm and 12 ohm. Okay, now we have come to the first part. Just make sure that there is any break in the electric circuit diagram. Fine. Now we can move to the second part. In this part, you have to connect an ammeter to measure the current. See, there are three resistors. So how many? But one thing, just remember that the current through each resistor is same in series combination. So you have to connect one ammeter here. So ammeter must be connected in series with the battery. So anywhere you can connect the ammeter. I am connecting the ammeter in this side. Okay, then mark the positive and negative terminal. So when you connect the ammeter, make sure that positive terminal of the ammeter must be connected to the positive terminal of the battery. So here is the positive side of the battery. So here will be the positive side, and negative terminal of the ammeter must be connected to the negative side of the battery. So here is the negative side, isn't it? Negative side and positive. Then one more question is that you have to connect a voltmeter to measure the potential difference across 12 ohm. So there are three resistors. The potential difference across each resistor will be different. So we have to connect the potential voltmeter in across the 12 ohm. So here, and a voltmeter must be connected in parallel with the resistor. Here will be the voltmeter. So it can be represented by V3 because each potential difference will be different. Here the potential difference of the R1 will be V1, R2 will be V2 and R3 will be V3. So I have represented as V3. Now we have completed drawing the circuit diagram. One more question is that you have to find the readings in the ammeter and voltmeter. The ammeter will show the current flowing through the circuit, that is the total current flowing through the circuit, and voltmeter will show the reading of the potential difference across the 12 ohm. So we have to find I and V3. In order to find I, we need the total potential difference, that is equal to 6 volt. We have V equal to 6 volt and total resistance also needed. Then how will you calculate the total resistance? We just apply the equation of equivalent resistance in series combination. So R is total resistance. Total resistance RS, since the series combination is represented by RS. RS equal to R1 plus R2 plus R3. Substitute the values. 5 plus 8 plus 12. The answer will be 25 ohm. So we have R is equal to 25 ohm and V is also already given, that is equal to 6 volt. If you have doubt, you can write 2 plus 2 plus 2, that is equal to 6 volt. Because in the question they have mentioned that a battery consisting of 3 cells, each having the value 2 volt. So this is the method how you have to calculate the total potential difference. Now we can find the current flowing through the circuit, that is ammeter reading. Ammeter reading will be equal to current through the circuit. That is I equal to V by R S. R is the total resistance. Substitute the values. that is 6 volt divided by what is total resistance, that is equal to 25 ohm. So the answer will be 0.24 ampere. This will be the reading in the ammeter. Now we got the reading for ammeter. So we can replace I equal to 0.24 ampere. Then what is our next thing? We have to find the potential difference across 12 ohm resistor. Then we can write the potential difference across 12 ohm resistor. That's equal to V3. What is equation V3 can be written as I into R3. I equal to 0.24 into, then what is R3, that is 12. Oh, so our answer will be 2.88. Then what is the unit of potential difference, that is volt. Now we got the ammeter reading as well as voltmeter reading. Then we can just write voltmeter reading. Voltmeter reading equal to 2.88 volt and ammeter reading equal to 0.24 ampere. Don't forget to write the units also.